In this video, we are going to consider a very important definition, the pump operating point. When we consider the efficiency and the reliability of pumps, we will use the operating point of the pumps as the major factor which defines pump parameters. In this video, we will consider the following topics: pump operating point, allowable operating range of a pump, why the operating point goes outside the allowable operating range, how to define whether the pump operates efficiently or not. I think that many of you have an understanding of pumps and system characteristics. In other lessons, we will consider pumps and system characteristics in more details. The operating point or duty point is the intersection of the pump curve and the system curve. It means that the pump and the system define the operation of each other. The pump works in the system not by themselves. This is the main idea we should keep in mind, but pump users very often forget about this. It is useless to consider the efficiency of a pump and its power consumption without considering the overall system. It means that energy transmitted to liquid by the pump is enough to push a defined volume of a liquid through the system. The operating point is the balance of energy. If a pump transfers more energy than the system needs, it will cause problems. Knowing the operating point, we can define other pump parameters, such as power, efficiency, and PSH. The most important moment in the pump operation is to know where the operating point lies when the pump works, especially where it lies relatively the best efficiency point in the pump operating range. The position of the operating point on the QH curve defines whether the pump operates effectively and reliably or not. Usually, the allowable operating range is between 0.7 and 1.1 of the best efficiency flow. Operating range is the range of a pump flow where the pump manufacturer guarantees efficient and reliable operation of his pump during a long time. You can find it on the Catalytic characteristics. On this graph, you can see how the position of the operating point changes depends on the system characteristic. It reminds us that the operation of the pump is defined by the system where the pump is installed. If we change the system curve, for example, we can do it by the valve, operating point moves along the QH curve. If the operating point is inside the allowable operating range, it provides efficient and reliable operation of a pump. When the operating point goes beyond the allowable operating range, we have low efficiency and very probably mechanical problems. Why the operating point goes beyond the allowable operating range? Very often it happens when the pump was wrongly selected. Usually was selected with excessive head. Users very often select pump with more head than the system needs. It happens because of the different reasons and can lead to serious problems during operation. You can see that the operating point 2 goes outside the operating range. Shaft power will be more and can exceed the motor power and to overload the motor. On this figure you can see that operating point for pump 2, which has more head, goes to the greater flow and power outside the operating range. The another reason when the pump operating point goes beyond the allowable operating range is when users select their pump control method without considering the pump and system curve. For example, such result can be when the speed control of a pump is applied in the system with a high static head. You can see as the operating point moves beyond the operating range as the speed reduced. Let's look at the diagram of a pump reliability, which shows how reliability depends on the position of the operating point on the QH curve relatively the allowable operating range. You can see that the reliability of a pump decreases when it operates beyond the operating range. More detailed information about the reliability of pumps is presented in the lesson Reliability of Pumps. Once again, when the pump operates outside the allowable operating range, it has low efficiency and mechanical problems, such as vibration, bearing failures, mechanical seal failures, shaft deflection, and so on. Main conclusions. The pump should be selected so that the operating point is always within the allowable operating range. The system curve should be considered first before selection of the pump control method. Define the position of operating point for all possible modes of operation. Make your pumping system efficient. If you need more information, please visit our website pumpsaudit.com. See you. Good luck.